Okay. The potential difference across the ends of a metallic wire in
Mhm.
electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. It's called Ohm's law.
Ohm's law, right? So, Rizwan and Faz,
Good evening, sir.
good evening. So, how are you doing? How's your school going?
Fine. Very good.
Okay, it's going fine. That's good. So, what you guys are studying at school?
So the
Which
Ohm's law.
Ohm's law? Okay. So, all of you are studying Ohm's law, some different laws as well.
No, sir, that's is the that parallel resistor.
Okay, parallel or series combination. What are the
Yes, sir.
parallel and series combinations?
So series combination. Yeah, a circuit which offers only one part of the current is known as series.
No, I didn't get the answer. I think I didn't get what you are saying because your voice is too low.
A circuit which offers only one part of the current known as a series circuit or a series combination.
What about the parallel combination? What's the definition is?
Which offers many
Which offer many parts.
pathways. Pathways.
Oh, path.
Mm.
Okay. What's the other quality of it?
Mhm.
Faz, what you
Yes,
are
sir.
studying at school?
So I'm studying light, reflection and refraction.
Okay. So how do you feel at school after studying over here?
So I now get what you're saying.
Okay. So what the topic or content you are studying now in school?
We just started.
Okay. So what was the first question asked by the teacher? What was the first question asked by the teacher? I'm asking you, Faz. They just started, they might have asked some question. Faz left. Jaslyn, hi, how are you doing? Jaslyn, are you there? And kindly, if possible, then open your cameras.
Hello, sir.
Just okay. So what you are studying at the school?
So we started this electricity chapter.
Okay. So what topic you have studied in electricity till now?
So
Hmm?
I
Which
finished till yeah, series and parallel combination.
okay, okay. So what is series and parallel combination?
Series combination is when the resistors are kept in a series, and parallel combinations when the resistors kept in parallel with each other, and
So
the current is constant in the series, and the potential difference is constant in the parallel.
okay, okay. Okay. So you derive the relation for both series and parallel?
Yes, sir.
Okay, okay. So which one offer the least resistance? Which one offer the
Parallel.
least parallel offer the least resistance, right? So Faz, What did you study in light? What did you study in light chapter? What did you study in the light chapter? Okay, I think you are not, your mic is not responding, but make sure to respond, okay? Otherwise, nothing. No, I won't read the chat. I won't read the chat. Try to fix your mic, okay? So we already completed the power definition of kilowatt ohm. Okay, that's the unit for the consumption of electric energy, right? We already covered the concept of electric energy, right? That's the kilowatt
Yes, sir.
hour, right? So did you practice some numericals over it?
Yes, sir.
Okay. If I'll go to read the chat box, then I may lose the. I also have 40 marks paper on Monday for science. Jaslyn, you have 40 marks paper. Okay. So Jaslyn, tell me, don't try to write over there. Okay. Tell me what is the topic of your test?
So we for the light chapter only from the refraction part onwards, and we have a human eye and colorful world.
Okay, that's human eye and colorful world, then light, and then electricity. 3 chapters.
No, sir. Refraction onwards from the light chapter and human eye and colorful world. That's it.
Okay. So when your exam is
Monday.
coming Monday.
Yes, sir.
Okay. So did you practice those chapters?
Yes, I finished.
Okay. Do you have if you will be having any doubts, you may ask later. Okay.
Yes, sir.
Okay. So for the time being, what we were doing, we solve few questions, right? Few numericals. Okay. So is there any problem in solving these numericals? So everyone got the concept, what is kilowatt hour and what is the use of it, how to calculate the energy consumption. Are you able to calculate the energy consumption at your home now? Can you read your electric meter and calculate the cost for the electricity? Can you do that? Can you read your electric meter and calculate the consumption of electricity? No one can do, right? You guys are not able to do that. So will you tell me how much electricity will be consumed in this meter, electric meter? Do you have any idea?
So which one?
This one. How much electricity is being consumed? we were able to solve this question, right? This numerical, right?
Yes,
But
sir.
how we will read the from the actual meters? How we will be reading from the actual meters? How we will be reading from the actual meters? Any idea? We don't have any idea, right? So by reading the electric bill, okay, if you will read the electric bill, I don't have any bill, okay, otherwise I could have shown you. It is taking bit time to check on the internet, so leave it for time being. So can we have a quick revision for this chapter? Can I ask few question and you guys answer me? Is this possible?
Yes.
Okay, if this possible, then let me go to the first slide. Okay. So first of all, tell me what is electric current? My question is, what is electric current?
It is the rate of flow of charge.
Electric current. Oh, that's good. Okay, that's rate of flow of charges. I is equal to
Q by T.
dq over
Q by
dt, right?
Yes.
dq over dt. Okay, what is the unit of current?
ampere.
Ampere, right? Ampere. So Ampere is the name of scientist, right? So that's why we write A capital. If you may have seen somewhere like Ampere, okay? Like Newton. Newton, it is the name of scientist. That's why we start the first letter with capital N. What is unit of charge?
Coulomb.
Coulomb, right?
Coulomb. Yes.
And unit of time?
Seconds.
Seconds.
Second. So in unit, it is Coulomb per second, right?
Yes.
Clear? So if it is clear, then okay, I think I'm having some network issue. I'm going to stop my video for the day. So if we are aware of current, so what do we mean by? Do current follow direction?
Yes.
Yes.
So it has direction and magnitude both, right? It has current singular. We will be current has direction plus magnitude, right? So do the current is vector quantity? Magnitude, right? So is current is vector quantity? Is current a vector quantity or scalar quantity?
Scalar.
Yes, it is a scalar quantity. Despite of having direction, it is a scalar quantity. What is the direction of current?
From positive to negative.
All.
From positive terminal to negative terminal,
Negative.
right? Okay,
Yes.
how it is positive? this is the negative positive terminal, this is negative terminal, right? So direction of current is from positive to negative terminal, right? And tell me what is the direction of charge if charge is electron?
Negative to positive. So I can't hear you. Hello.
Sir,
Sorry, you're lagging.
So no more.
Okay, sorry. I had some network issue. That's why we got disconnected. Okay. I'm audible.
Yes, sir.
Yes, sir.
So actually, current have directions, but it doesn't follow the vector addition rule. Okay. That's why it is not a vector quantity. Okay. It's clear.
Yes, sir.
Yes, sir.
So how we measure the current? Okay, suppose this is the point. Okay, we are giving current I1 over here, I2 over, sorry.
Sir, are you screen sharing?
Actually I asked admin to share the screen. They have disabled. So let me give me 1 second.
Yes, sir.
So how we do the operation? The screen is visible.
Yes, sir.
Okay, so my question was how we will do how we do the addition or subtraction of currents. Suppose current I1 is coming at this point, current I2 is also coming at this point, and current I3 is going away from this point, right? So how we will write the total current at point P? This is I3. This is I. So how much current will be at point P? How we will write it? See, I1 and I2 is coming toward point P and I3 is leaving. So how much current will be at point P?
Um, half of half of I2 and I3.
Half of I2 plus I3, like that.
Yes, like that, sir.
What about Govita? What you say?
I mean half of the whole current.
Half of the whole term. What about Jaslyn? What about Madiha? Actually, I have some network issue. That's why I disabled the camera. Okay, video. So actually, see, the same directional current will be added. So I1 and I2 has the same direction because these two currents are coming towards point P. So this is incoming current. I1, I2 is incoming current. So we will add the incoming current and subtract the outgoing current, right? The net current at point P will be, we will be adding the incoming currents and subtracting the outgoing currents. Clear? So incoming currents are I1 plus I2. So I1 plus I2 will be added and I3 will be subtracted and this will become equal to 0. Clear? Is this
Sir, why
clear?
0? Sir, why 0?
The net current, net coming current equal to net going current. Okay, outgoing current. So net coming current is I1 plus I2. That is the outgoing current. Clear?
Yes, sir.
Yes, sir.
So it means that there are two pipes filled with electrons or charges. So we have added two pipes at one point. That's two inlet and one is outlet. That is I3. So it will be, the operation will be like this. We don't have any vector addition rule like Pythagoras or some other. That's why it is being called a scalar quantity. Clear?
Yes,
Yes,
sir.
sir.
Okay. So this is one of the important property of current, right? That's why we did in parallel combination. Now there was three arms, right? So like that. There was resistance, right? Again, it was like that. So this I1, I2, and I3. Again, it sums to I, right? So all are coming to one point and going from this, yeah, you may say that all are coming at one point. I is coming at one point and it is being distributed. I1, I2, and I3. That's why I was
Sir, I can't hear you.
extremely sorry. Okay, sorry. I'm extremely sorry. Is the screen visible?
Yes, sir.
So this was the reason that we have written like I1, I is equal to I1 plus I2 plus I3 in parallel combination, right? In parallel combination. Clear? So my next point is we discussed the current, what is the direction of currents, how it's subtracted. Till this point, it's clear.
Yes, sir.
Concept is clear. Okay. So
Sir, you're lagging.
this was the don't know what
Sir, I can't hear you.
I'm still uh
Yes, sir.
Oh, you're lagging.
or because issue. Question is how do we add potential? Add potentials in how do we add battery
I didn't got it.
how do we add batteries? Means that if we have more than okay, this is negative terminal, this is positive terminal, like that. This is positive terminal, this is negative terminal. So how we so how we add it? I'm not at all.
Sir, we can't hear you. You're lagging.
I'm just just हाँ, तुम्हारे पास डाटा है क्या मोबाइल में, या फिर मेरा रिचार्ज हुआ नहीं, मतलब डाटा खत्म हो गया है? हाँ, डाटा नहीं है। दिखाता नहीं, यहाँ क्यों करता है ना। Mhm. Hi. Today I think there is some network issue. That's why I'm not able to connect you in the proper way. Still, I'm lagging.
No, sir.
So,
Okay. So I asked that how do we connect the batteries? This was the way we connected the current. Okay. And then how do we connect the batteries?
Are you sharing screen?
I'm trying. It's not being shared.
No, sir.
Uh,
We connect the battery from like uh, from positive to negative. Then the next battery will be again. It will the negative part will be connected to the positive part. Right, sir?
yes, yes, right. So, what do we mean by potential and potential differences? Potential difference.
The work done by the electric current
My
charge.
question is, my
Yes, sir.
question is, what is electric potential and potential difference?
The amount of work needed to move a reference point to a specific point against an electric field.
That's called electric potential, right?
Yes, sir.
So amount of work done in bringing positive charge or any specific charge from one point to another point.
Yes, sir.
So that's called electric potential. What's the mathematical form of electric potential?
V is equal to W by Q.
So
V is W by Q. That's
Yes,
the
sir.
potential difference, right? Between 2 points.
yes, sir.
Okay. So how the charge flow in electric circuit? How do charge flow in electric circuit? Question is
From
clear. How
negative
do
to
charge
positive.
flow? Okay. That's called in another way we can say that's the potential difference.
Yes.
So from higher potential to lower potential, the difference in still screen is not being shared now.
No,
No,
sir.
sir, not being said.
It's showing me loading. Yesterday I had a good class over here with this network only, but today I'm having problem. It's still showing it's loading. Maybe some issue from other side. So potential difference, the difference in electric potential between 2 points in circuit. So we saw in number of situation where the high potential and low potential current flows from the electric pole to our home appliance, right?
Yes, sir.
So that's, we can say, the electric potential. So hope so we should stop because if a screen is not being shared, so it's not that much useful, right?
Yes, sir.
So we'll do it next time. So now we have to revise the chapters, right? Uh, one day we will take to revise this electricity, and then one day human eyes, or 1 and 1.5 days, and same amount of time for the light and